such as the Higgs boson, using these particle accelerators from CERN or Fermi Lab. But we found a problem. Why are these particle accelerators only accessible to billion-dollar institutions? Is it possible to construct some sort of cost-efficient and effective particle accelerator? So Sumved, sitting there with this book, exclaims, "Hey, let's build one." Now, Lucas and I had an interesting first impression of Sumved. When we first met him, he was an ambitious freshman. I remember him coming up to me with his physics textbook, asking me to teach him about solenoids and induction. Later, I found out he started to build a self-sufficient magnetic electric generator.
It seemed like a good idea at the time, but then
I told them magnets couldn't do work on their own, and so it wouldn't work.
he basically crushed my dreams that day. Regardless, I continued my research, and finally inspiration hit me. But inspiration can come from anywhere. For example, you're looking at a coin, you can think, oh, why not build a particle accelerator? Which is basically what happened to me.
But here's what I like about Sumved. He has a drive. The drive that allows him to actually commit to some sort of experiment like this. We all have great ideas, but how often do we commit to these ideas in our free time? How often do you go up to someone and say, "Hey, I'm building a particle accelerator for fun"?
I remember when I first started Sumved, I was studying after school for a physics test, and he came up to me and introduced himself. At first, I dismissed him as just another classmate, probably my younger brother. However, he caught my attention by commenting on the physics that I was studying. Then, we began discussing some quantum mechanics and string theory. Things got more interesting, however, when we emptied our backpacks. I took out a string theory book that I was rereading, and he took out a particle physics book that he admittedly was having some trouble with. I had studied much of particle physics as a sophomore, so I helped him with some of the more difficult chapters. He then told me that he was working on constructing a particle accelerator. I was really skeptical of this because I doubted that a student-made particle accelerator would be strong enough to really be used for anything. However, I then learned about the many types of accelerators in use today.
Accelerators were once almost exclusively used for physics research, but are now commonly used for analysis, security, production, and even medicine. Through the creation of X-rays and particle beams, accelerators are capable of analyzing materials and scanning large objects for security threats. High-energy protons can be directed towards targets to create radioactive atoms for industrial purposes. X-rays and particle beams can also be directed towards tumors to help treat cancer patients. There are about 18,000 active accelerators around the world today, 4,000 of which are stationed in the United States. We came to the realization that of the numerous ways in which an accelerator is small and easily transportable and has many capabilities, is useful in this world. This drove us to create this accelerator and improve the designs that currently exist today.
But starting a project wasn't exactly easy. The first time we ever tried building one, we Googled how to build a particle accelerator on Google. It wasn't the smartest idea. After weeks of starting the project, we did our fair share of research, but in different ways. We possess an interesting set of skills. We have a sophomore year, a junior year, and a senior, but we all have a love for physics. Here, what I did was, instead of basing my ideas off of the current research and the papers that I've been reading, I based it off from the basis of the math and the fundamental concepts of just magnetism, electricity, and relativity. And from there, I tried to determine the parameters in order to optimize our machine. On the other hand, Lucas and Sumved had a different approach.
Lucas and I looked at the engineering aspect of this project. We both spent hours researching, and I myself have compiled gigabytes of data on research articles. I also spent hours on AutoCAD designing parts for our machine. Using Michael's parameters and Lucas and myself's design, we created a program in Java that's able to optimize the efficiency of the particle accelerator.
We then demonstrated that our current design for the accelerator, an octagon with 60 centimeter sides, would be sufficient enough to energize particles to levels that would rival other accelerators. With the finalization of this design, we moved on to the publication of our product.
Me and Michael began writing our proposal for the 2013 MIT Think competition back in December. This competition was ideal for the compilation of our ideas, as well as the fundamentalization of our plan for creation of this project. We talked to Lucas about our ideas, and he gave us advice. We both believed strongly that he was a capable person in this project. After getting an honorable mention in this project, we decided that it was time to start building it. So as a result, we Carefree High School started emailing companies as well as colleges about our crazy idea and asking for grants and funding. They all said about the same thing, that our project is very interesting and very well thought out, but we just don't want to give you money. As a result, we ended up thinking about different ways in which we can optimize our project.
And so we went through a lot. And though we didn't construct the particle accelerator itself yet, we've gone through an enormous amount of progress. So it doesn't take a special person to build something like a particle accelerator. We all have these ideas. You are all sitting here at a top high school learning all these math courses and science courses. It doesn't take just a senior research project or an internship for you to start building something. It just takes some ambition, like putting something in your head. And though Lucas and I were skeptical at first, we went through a lot of progress.
We plan to construct a miniature, efficient particle accelerator soon in the future. Hopefully, this accelerator will be powerful enough to be used in different fields of research and to advance further experiments. With more hard work and perseverance, we will make this dream a reality. Thank you very much.